Okay, this is the main page of the software. As you see in this point, the software is searching for an ECU. Now there is no ECU connected, so the software will make a full selection of full checking of the serial port. It could be Bluetooth ports or serial link interface, and if the software doesn't find any ECU, will switch to offline mode. Now we connect an ECU. To make another search of the ECU, you have to click here with the left mouse button. Okay, now is checking data and retrieving data from ECU. Okay, at the first connection of a new ECU, it will be prompted about the kind of kit that so we have to choose a configuration. For example, we have two configurations, one for LPG and one for CNG. We will make an example with LPG, and so the default values will be stored in the ECU. Okay, now we are connected and the default values are stored in. There is no update available. In this case we have the latest firmware on the ECU. As you see here, ECU firmware is the one that is stored in the ECU, and available firmware is the one that is included in the software package. There is no last hatches here because the ECU is new, and the kit is the 8009 LPG kit. One thing about the connection button is that you can make a full search of serial communication ports when you click with the left mouse button, but if you click with the right mouse button you can choose which port to use. For example, USB port. And the same thing about the languages. You can select the languages by clicking clicking with the left mouse button here, so you can change. In this case we can switch from Italian to English, for example. Otherwise you can click with the right mouse button and select the language that you want. Now we have a little overview of software functionalities. Here we have auto calibration, that is the main process that has to be done at the first connection with the ECU, and we will see in the detail after. And we have a mapping section. Here we change the calibration of the car after the auto calibration. We can manage the map of the car. We can manage the adaptivity. We have two kind of adaptivity modes. We can select if in some condition we need to switch to petrol, for example on idle or at full power, and we can see if we can change some other parameters about that changes the carburation of the vehicle. Here we have the adaptivity section of the OBD that is available only in 48 pins ECU and not in the 32 one. Okay, and after this we have a configuration section when we can reset the ECU to default parameters, changing the kit that we have selected before, changing cylinder, injectors and so on, but a part of this selection will be asked in auto calibration section, so we will see in the detail after. We can change sensor and we can connect lambda sensor here and so on. And we have a diagnosis section here with error management and some kind of useful utilities to check if something is going wrong with the ECU, information about working time, and a little logger that can be useful for checking some kind of problems in the ECU, but we will see after. Welcome to a J400 training, section 2. In this section we'll see how to make an auto calibration. Okay, so we start the process. The engine is off. We have to turn on the engine. And we have to wait that the reducer temperature it reaches 50 degrees. This is for LPG. In CNG systems, the temperature needed is a little lower than this. So, here we can see RPM, gas pressure, and the regulator temperature. Below here, we have the status of the ECU that is on petrol, an average of petrol injection times, and also RPM, and the map sensor, manifold absolute pressure, reducer temperature, gas temperature, and so on. So, at first time, we have to select the number of cylinder of the car. So, if it is a 4-cylinder, we leave here as it is, or we can change the number of cylinder. Then we have to choose the engine type, that it could be aspirated or turbo or valvetronic. We can select the injectors that are installed on the car. We have many injectors type, but it depends from the kit. And for last, we have to choose the level sensor. Even in this case, we have a multiple selection. Okay, so we can go on. Now we have to press deeply the accelerator pedal to check which is the larger petrol injection time. Okay, just a couple of times. Okay, and then we can go on. This part it can be skipped because it's not needed for calibration purposes, but it's better to do it. Okay. Now we have to keep the engine on idle without loads. So no lights and no conditioning and so on. Here you get the petrol time injection. Okay, now we lead the engine above 2500 RPM. Okay, from this point we have to keep the accelerator steady even if RPM changes. Okay, in this point we have switched to gas. And you can see in nozzle size bar how far we are. Here we have the latest part of calibration on idle. And nozzle size is changing again. We have on this vehicle we have nozzles that are a little too big, but the car is going well, however. Okay, so we are in the yellow section, so no problem, it's okay. Now here we can choose the adaptivity type. We will make just the one of these two to see the latest part of the auto calibration, because there is another one that is available only with map adaptivity enabled. So the OBD and disabling adaptivity, we will end the auto calibration. Selecting or guided one or customer map we will make you to make the last step of the calibration. So we see one of this. Okay, we have to accelerate slightly. Okay, a little bit. Yeah, we have to make all the red circle turn green while slowly we accelerate. Okay, it's not needed to make them all, but it's suggested. Okay, so the calibration is finished. Welcome to a J400 training, section 3. In this part of the training we will see the mapping section. This is the main map of the ECU. Here you can see RPM, and here you can see petrol injection times. Okay, the values you see here in the map means the amount of gas we use for injection, and it's referred by RPM and petrol injection times. We calculate this map during the auto calibration, and you can change it later if you need to make some adjustment. The auto calibration not cover all the times and all the section of the map, because it's made on idle, so we haven't all the information about how the vehicle is running in all the condition. But these maps are calculated from a series of tests that we made, so usually are quite near to the optimal map, but not every times. So sometimes you need to make a little bit of adjust. So to change the values of the map, you have different ways. You can select parts that you need to change and increase the values, and as you increase the values, you increase the amount of gas that you give in the region you have selected. Or for example, you can select another region, and with the enter key you can add or subtract the amount of points you want. For example, 20 points. Selecting here linear, we will add 20 points to the selected zone. Okay, as you see, this region now is a different color because it has more higher values. Okay, you can undo the last modify with this button, so we return to before our last modifying. And obviously, if you need to make little adjustment, you can select the part of map you want, even the whole map, and using plus button and minus button. Okay, or for example, maybe you want to have the same values in a section, for example like this. Maybe we can set absolute value, and so we can put, for example, 70. Okay, and now you see that the whole region here had the same value. Okay, so we came back to the first one. Okay, so there is a way to reset the map to default values. These are default values from before making an auto calibration. So if you reset the map, you will lose the auto calibration you have done before. Another thing that we can see here are these bars. Red bar, it will be always here in 0 point, 1 point, because it's how is changing time injection, because it's not always at the same value you see here. And the green bar is the one that tells you how much we are far from the petrol injection. I mean, for example, now I will switch to gas. Now we are on petrol, as you see here, and we have no injection timing of gas. Here you see that we are on petrol, and on the switch we are on petrol. So clicking here or pushing the switch on the car will get you on gas. Okay, as you see, the cursor here has been colored differently. You see that it's green, so it means that we are on gas. This is a quite good calibration, because we have a little bit difference from the petrol. So you see 5 points, 0 point, and so on. So we are very near to petrol injection time in this area, because we are on idle in this moment. So, but if we want, we can change the values of the map, so we can see how the petrol time injection is changing. For example, I will add 20 point to the whole map. Okay, so now you see that we are far from the point of before. Time injection on petrol is lowering, because we are too rich, because higher number means richer mixture and lower number means lean mixture. Okay, so we get back to our first map that was tuned in the right way. So you see, here we are, and this is a good calibration. When you have values below, I think 5 or maybe even 10 points on idle, you are not so far from the right calibration, so you can leave the numbers as it is. But if you have more difference, I mean, for example 20 points, you should change this map. And we now will skip map adaptivity and OBD adaptivity. We'll see them later. We can take a look to gas and petrol section. Here we can select to making some parts of gas running forced to be on petrol. For example, on idle, there are some cars that got some problem on idle with, for example, on CNG cars, and when we release on idle, we can have some problem, and sometimes engines turns off. So we can choose, for example, return only, and this kind of procedure will take us to have a little time of petrol injection while we are returning on idle. Now I make an example. So now we are on gas. Okay, so I will get high RPM, for example 2000, and I will release the accelerator. Okay, now you see that this LED will blink for a moment. It takes a short time, I think about a second, for example. Okay, you see. So in this case, for this time that you see that the LED lights on, then the engine will turn to petrol. And there is even the possibility to make petrol steady. So in this case, we will have always petrol on idle. So As you see here, we are on petrol because the LED is light on. Here we have petrol, as you see, but when I get over this threshold, okay, LED turns off and we are on gas. Okay, and when we get down from this threshold, we will return to petrol. Some car got some problem about stability on idle, and so we need to make this kind of adjustment. You can select obviously at what RPM making this function working. Okay, we'll back to gas. Yeah, we have the same management on power. So here we have two kinds of selection. We have a simply petrol selection. We can make working range that we want. We will leave this for this example. But we have even injection time that is needed for switching on petrol. For example, on idle, I can get over to 2000 RPM, but I will not switch to petrol. As you see, the LED is still off, and here we are on gas, because we can choose the amount of time injection of petrol that we need to switch on petrol. This is needed for cars, for example, that need more power at higher RPM, very powerful car, and there are some conditions that we can't give enough gas, enough LPG or enough CNG for making the car working in the right way, so we switch to petrol for security reason or even for having more power. And for the same reason, I will make you see, as we done before, we can make, for example, 4 milliseconds. Now we will try on idle to get. Okay, I will get some tests. As you see here, lights turns on. We can get on petrol. Okay, because we have a time injection of petrol that is above 4 milliseconds. Okay. In the same way, we have a petrol contribution. It works almost in the similar way. There are the same parameters, so we have RPM range and injection time that is needed for petrol contribution. In this case, we have mixture that is composed by petrol and gas. So in this case, we have a little amount of petrols that can helps the CNG, for example, to burn correctly. And the amount of petrol is very small amount. We should use 1 millisecond, 1.5, maximum 2 milliseconds is used. It's very useful for CNG cars when getting out of idle. It gets some more power because CNG burns first, so sometimes you need no timing advanced processor and things like this. The main thing about petrol contribution is that you need to check it on the road. So you have to check if it's working good, because not in all cars we have the same response from the engine and from the petrol ECU. And we have the firing order of the engine. It's detected during the auto calibration. In this case, we have a sequential type of engine. It could be full group or half group. And now the software is saying to us that we are phased with the firing order. And here we have another indication about a petrol switch at high RPM. This is a security functionality that it activates when we have too large gas injection times, so for security reason we switch on petrol. You will see here the LED turns on when you are at very high RPM, for example 5000 or 6000, and you are requesting very high power to the engine. Here we can see if the compensations are enabled. So we have three kinds of compensation: reducer for water, and gas temperature that we detect on the injectors, and the gas pressure compensation, so that is needed when maybe we are on low pressure gas or there are some changes in the reducer. And we have an extra injection filter. It is used for filtering extra injection, and there are sometimes some cars make small injections, and maybe if on petrol there are no problem about this, with gas you can have some troubles while driving the car. So you can filter this extra injection, but we will see in a separate section how to make this, because it's not so easy to detect if you need extra injection or not. Here we have a functionality that can make a richer or leaner mixture in transit state, in acceleration mainly. Okay, so you can choose, for example, to having 10% or 30 is too much, but 20 or 10% of increase on acceleration, and this is could be useful for cars that are a little bit leaner during the accelerations. Or maybe you can have a decrease of gas, mainly in CNG systems, because CNG in acceleration could bring to a richer mixture and the car lose power. So to having a leaner mixture and to have a little bit more of power while accelerating, you can decrease here, I think about 10%. However, you have to see on the car itself, and you will have a better performances. Welcome to a J400 training, section 4. In this section we'll see how the Adaptivity map works. Here you can see the map Adaptivity page. Now map Adaptivity is disabled, but if you have selected or guided one or the customer one during the auto calibration, you will arrive in this page with the already selected one of this. Now we will try the guided one. Okay, so now we are on Petrol. Yep, as you see, these squares are changing colors, and the meaning of these squares is that there is some map in the ECU that detect the petrol injection times, and we call it samples, and as you see here, in this way are increasing RPM, and in this way it's increasing map. So it's important that for using this kind of adaptivity we have not valvetronic car, for example. We need that the manifold absolute pressure is working in a normal way. So on idle we have 0.30, and when we are on full power we have 1 bar or above, if we are talking about turbo cars. Okay, but aspirated one we stay, however, under 1 bar or so on. Here you see the cursor in the exact position. Here we are. So if I'm increasing, I'm on idle now. If I am increasing RPM, you see that this bar is moving. Okay, and we are changing the square. So as you see, it's changing color even here, and so even in this square we need to have different samples for every square, and the square will turn green. We need to have at least 8 green squares, even if it's better to have them all, but it's quite simple. And another thing is that you see a gray region here and here. The gray region are a region where adaptivity doesn't work, because it's maybe a region that doesn't need to be adapted, or a region, for example here, that is at full power. It's a region that usually the car have no lambda control on the mixture, so it works maybe with a pre-mapping, and the values of injection time that we read here are not useful for the map adaptivity. Take the rest of the samples. We need to get on the road. It's not a long travel, you will see. Quite fast as sampling. You need just to have a long road to have a little bit of stability overall for the high power section. So we are sampling it in real time, so you can understand how fast it is. This should be enough, but for a more accurate sampling I will take the whole squares. If you want to have a more accurate sampling, you can even drive for a longer time, and the ECU will detect any other samples, and will make an average from samples that you take before. So taking this sampling longer, it will not be a waste of time, but maybe you'll get an accurate sampling section. Okay, as you see here, phase 2, we have to acquire gas samples, so now we switch to gas. Okay, and as made before with petrol, we have to make the same way with gas. You can make the first row of squares here on idle. It is more simple, and it will take a very short time. Okay, and now we're going on the road. It is possible to enable this flag sound. It will make little sound when we are on a section that is sampleless, so the driver can keep an eye on the road, and with the sound he can detect if he is running in a place of the Adaptivity map that it's empty as samples, and so he can be more safe while driving. Now we have all samples, petrol and gas samples, and we are in phase 3, so we have enough gas and petrol samples, so we can make an automatic computation of the Adaptivity map. So we click here, now you see petrol samples and gas samples turned to a darker color, because now are not so useful for us. We now need to see only the result map, is the thing we have to take a look to. Here you see that the graded region has changed, because when we made the auto calibration we see that the idle point is this. So due to the fact that the auto calibration get a good calibration and good mixture for idle, we can avoid to adapt here because it's not needed. And the other section you see here, there are some red zones and some brighter zones here. So red zones means that here we had a linear mixture, so map adaptivity had increased a little bit the mixture here to have a better mixture. And the light blue regions here are regions that have no samples, so a region that are not adapting in this moment. And otherwise this is not the case, because we have a mainly red region, but while red means lean mixture, yellow colors mean rich mixture. Okay, so this is a pre-mapping that the software calculates, checking the petrol and the gas samples. From this point now the ECU will continue to adapt itself, taking more and more gas samples while driving. Now we get back on the road. You will see that gas samples are still changing and still acquiring new samples. And while we continue to acquire samples, the result map will changing a little bit. So it's normal that you see that the gas samples are turning from green to red again, because the ECU is storing the information in the result map, and then it will erase the sample on gas for taking another one. If you have a condition that the gas samples map remains all green squares, it means that every region of the result map has been optimized for injection time, so practically you have the same injection time when you're on petrol as when you are on gas, but it's quite impossible to have a condition like this one. To check the difference in milliseconds that you have running on gas or running on petrol about injection timing, you can click here on show gap, and you will see in every single point how far you are from the optimal mixture. You will see that sometimes the red circles, it disappears because we are running in a point that maybe we have no samples, or maybe we are taking it. While the red circle is in the green square, it means that we are in tolerance, so there is a very little difference from injection time from petrol to gas. While when the red circle go in the yellow bar, so it goes out from the green square, it means that we are a little bit far away, and the ECU will make some adjustment to the result map to make the time match. Okay, now we try the customer adaptivity. Now we enable it. Okay. So when we are in a customer adaptivity mode, we have a darker color here on petrol samples and gas samples, because we are not supposed to make the 9 squares as made with the guided one, but the ECU will check when the petrol samples are enough and automatically will switch to gas. The meaning of this kind of adaptivity, it is that the installer can make just an auto calibration and a little bit of checking, and then he can give the car to the customer, so he will drive the car on petrol until the ECU get enough samples, and then he will switch automatically to gas. So this is very useful in condition where the installer cannot drive the car by itself, maybe because he is alone, or maybe because he lives in a very trafficked area, or something like that. So in this case, if we try to switch to gas, you see here below that there is a different type of flashing light here, and you will see that we are still on petrol. Okay, so now we will drive. It will take longer, so this part will be fast forwarded, and because this must be a little bit accurate, because it's supposed to be done without the laptop connected, because it's not needed. And when we are on petrol, we had enough samples, the ECU will switch automatically to gas, and we will hear a beep sound from the switch. So now I'm starting to driving, and we will see how time it takes for having all the samples we need, and then we will switch to gas automatically. You can even make the idle accelerating, like done with the guided one, because it works maybe in the same way. So it is useful because it catches more samples and is quite accurate. so we can make it, and then we can go back to the road. Okay, now as you have heard, the switch has beeped, and you see that we are on gas now. Everything is running smoothly, so we had enough samples, and now we are adapting. Welcome to a J400 training, section 5. In this section we will see how OBD Adaptivity works. Okay, this is the OBD Adaptivity page. Here you can see some information about OBD. This is for the OBD connection. So if we have a CAN vehicle, we have to connect on 6 and 14, and if we have an ISO vehicle, we have to connect the pin 7 of the OBD connector. To enable OBD Adaptivity, we have to click this, connect OBD. This must be done with the car, the engine on, or at least the key on. Now the ECU is checking which standard is the right one of this car. We have an ISO car here, so the standard OBD that is detected automatically is ISO fast. Okay. Now the adaptivity is enabled, and the fuel trim are standard because are normal fuel trim. So normal fuel trims are fuel trims that are, for example, you see on petrol, that are leading to 0. This is a little bit far from 0, but it is not a problem, it's good. This is not new car or a perfect car, so it's a testing car, so maybe the fuel trim are not always to 0 as it should be. And in standard fuel trims means that positive values are leading to lean mixture, and negative values are meaning very rich mixture. So we can have even inverted fuel trims. So positive numbers of fuel trims means rich mixture, and the negative numbers means lean mixture. For last choice, we had Fiat fuel trims that are for some Fiat cars that have a strange kind of fuel trims that are not leading to 0. Optimal values is not 0, but it's 99 or 100. And about adaptivity, we can choose to let it enable. Disable will disconnect the OBD. And frozen type. When we use the frozen adaptivity, we are not adapting in any way, but we are just connecting to OBD to see fuel trims working. So this could be useful if you don't want to use adaptivity, but we want to see how the car is going. In this case, you see that the green square it turned to yellow because it means that Adaptivity is not working, but it's in some way enabled. Yeah, because it's frozen. But if we return to enable 1, this will turn green. So this is mean that the Adaptivity is fully working and functional. Here we have an average of OBD trims, and that means that in this case we are running good, but it's obvious we are on Petrol, so the car on Petrol must be going well and must be centered here. And here we have some additional information about how many ECU are on this OBD channel and the kind of standard and the address of the ECU. These are information mainly for technical reason. So here we have the status, so closed loop. So the vehicle is changing the carburation in this way, but there are some condition, for example high acceleration or cutoff, that you see that we go in open loop condition. In open loop condition, the car it doesn't changing petrol injection time with a feedback from lambda and so on, but petrol ECU is running with pre-mapping. And so now we switch on gas. Okay, now you see that the fuel trim are changing, but not so much. In this case we had a good idle, so you see fast and slow fuel trim are very similar. Maybe one is the opposite of the other, but very lower values, very near to zero. You see that here on the right we had cursor map like the one seen in map Adaptivity. There is a region that is grayed because OBD Adaptivity it doesn't work in release condition. If I had a strong acceleration, you see that here the fuel trims turn red, because it means that we are in open loop, and it means that we will not take these values as good. Okay, we are running on the road now, we're moving, so we can see if OBD Adaptivity is working. And we have a little bit lean mixture, so results map is increasing, as you see. If you can stay steady in a single point, you will see that the ECU will bring the red circle, that means the average here, will be brought back in the green square. So that means that the fuel trims are running in the right way. Yeah, here we are, for example, in open loop, so we will not adapt here. You see that this section turned to red. Okay, and we are again in closed loop. Another useful tool is this one, Erase Error Mill. It can turn off the check engine light if maybe it has been turned on by some mistake made while setting up the system, or for example a wrong mapping or wrong injector connection and so on. And this is useful because you can erase errors and sometimes even reset fuel trim by just clicking here and without connecting diagnosis devices or OBD tester and something like that. And as we have seen in map adaptivity, here we have the instant OBD correction that the ECU, the gas ECU, is making. And here we are just a little bit too rich, you know. Okay, and moreover, here you see the lambda read by OBD. This is the post catalyst one. It's important sometimes to see if the catalyst is working in the right way, or to see if the mixture is too rich when we are on full power. And this is all about OBD adaptivity. Welcome to a J400 training, section 6. In this section we'll see how to configure properly the ECU and its sensors. Here in configuration section we have the main selection, that is the kit. We have seen this selection before because it's a forced selection you have to do when you connect for the first time the ECU. However, you can remake the selection if maybe you had a mistake or you have already set up the ECU on another car and so on. However, to reset ECU parameter you can or change the kit, so you can select the LPG and the CNG one, for example, or by clicking here in reset ECU parameters, that will keep the kit as it is, so we will remain in LPG kit, and it will reset to default values. Here we have two selections that we already made during the auto calibration: the number of cylinder and the injectors. Usually you make this selection during the auto calibration, so it's not needed to change it in a second time. But maybe you change something, you made some tests and so on, so you will need to change it in a second time. Here we can select the source of RPM signal. Usually you can take it from RPM wire. We have a brown wire that we usually connect on coil signal or Petrol ECU signal, and you can take RPM from there. It's usually the better choice, but sometimes you will have some trouble to find the right signal, so it is possible to take RPM signal from injectors, Petrol injectors. Obviously there is a restriction while using this kind of selection, because idle and power management, anticipating the injection and so on will not be allowed to be made. So now if we leave here RPM signal from injectors, you will see that if we go in mapping and then in gas petrol section, we will not allowed to use petrol on idle, for example. We are not to use contribution, for example, and so on. So in injector selection we have a multiplier to select if the RPM are not read in the right way. So we will make an example. So in this car we have 2 multiplier, but sometimes you will have to change it, for example to 1, and so you will see that RPM are half respect to before. In the same way, If you have RPM wire connected, you can select the number of coils to make the RPM match as you see in the cockpit of the car. This procedure is not needed usually because during the auto calibration the software make this selection in automatic way. Here we can select the parameters about the changeover, so the RPM at which we want to change over automatically when there is the right temperature and it has passed a little bit of time from the starting of the engine. And we can select even if you want to change over in acceleration or deceleration. Here below you can select some kind of engines. We have Valtronic engines, like some kind of BMW that usually works on 1 bar in every condition. So in a Valtronic car we cannot use Adaptivity, and enabling start and stop will allow us to restart directly on gas during the start and stop if there are the right condition, of course. And there is selection for multi-air engine like Fiat and so on. And at last we have a turbo engine flag. Enable this, we will allow us to make an optimized adaptivity overall, and we have a different kind of diagnosis on pressure. Then we have the sensor section. Here you see the type of pressure sensor, the water temperature sensor. Usually you cannot change this sensor because are the ones that are selected for the kit. The only sensor you can change is the level sensor. So here we have a little selection of sensor, but we have more than the one you see here. And it is possible to change the threshold for every step of the level sensor. Usually it's shown if you select a custom one, that it could be normal or inverted. Here we have the lambda sensor selection. We can connect with the proper wire, a purple wire, lambda sensor. Now in this car it's connected the front one. Front is the pre-catalyst and rear is the post-catalyst. So this one is after the catalyst and this is before. Okay, so you now here you can see the voltage of the signal of the lambda sensor. Welcome to our software training 2.05 version. In this section we'll see all the new features that have been introduced in this release of the software. First of all, in the main page we can see two new buttons. The biggest one, here on the left, is the OBD scan tool that we'll see in detail later. While this one on the right, here, the magnify lens, is the index tool. By clicking here, you can see in one page all the most relevant information about the connected ECU. As you see here, file name, notes, kit, cylinder, injectors, and so on. This tool is very useful to take a glance about which strategies are enabled in the ECU, or even for keeping track of the installation data. This section has been updated with minor features like an improved accuracy in targeting injection times, or allowing the installer to select during the wizard if RPM signal must be read from RPM wire or simply from petrol injections. Then switch on the mapping section. Okay, here we only changed the logic of the bars here above on the right. Okay. Okay, now we are on Petrol. You can see that is the Petrol reference bar is green. Now the engine is steady, so we switch on gas. Okay, okay, here we are. We are a little bit rich. We should add some point here in this region. So the procedure is more or less the same of the previous software version, you know. Sure enough, the new feature is that if we're driving and for some reason we change a little bit RPM on engine load, the petrol bar will turn red to warn us that we lose our previous reference, and we are suggested to go back to petrol for a little bit to acquire a new reference and then switch one more to gas to check the mixture. So for example, I go back on petrol, yeah, and then I switch again on gas. So you see we are still a little bit rich, and if I go over RPM or changing a little bit the load, as you see here, it turns red. It means that my reference is wrong. Okay? Okay, let's go further on gas petrol tab here. Okay, we need to activate the express section. So we'll see here that we have a selectable numbers of cycles in the anticipate section. Well, this number means how many engine cycles we should anticipate when we use this feature. On a 4-cylinder car, like this one, you can anticipate maximum 3 cycles. Anyway, this parameter is useful in some CNG vehicle, but there's no rule about that. You have to try and see how it works. Okay? It's very simple. You select how many cycles, okay, and then you click on anticipate. And now here you will see about how many cycles are anticipated here. Okay, to anticipate a different number of cycles, restore the previous firing order, the standard one, and then you change here and anticipate again. Obviously you must be on petrol when you are doing this, and then you try on gas. Okay, so now we switch to the modify carburation tab here. Okay, you will see that we have here a new entry, the gas pressure compensation recalculate. Okay, and this option will set the gas pressure compensation center on the actual value of the gas pressure. You have to pay attention to this feature. Use it only if you cannot auto-calibrate a vehicle, or maybe if you need to replace a reducer and the new one have no way to mechanically regulate the pressure, and its working pressure is different from the previous one. Okay? In any case, you have to check the mapping of the vehicle after adjusting these parameters. However, to recalculate the compensation, you must be on gas. Okay, so here we are. We have made an auto calibration before, so we are very near to the oldest gas pressure centering. However, we can recalculate it anyway, just to see how it works. Now you see that the average here for regulation is 1.18. Okay, so if you click on recalculate, this is a warm message. Okay, and now the pressure is centered on the compensation is centered on the gas pressure of the regulation of the gas pressure. Okay, so this is more or less the way to do it. Okay, next step, OBD Adaptivity. Yeah, here you'll find many new features. Okay, let's start with the most important one, the selective errors erase. Well, enabling this feature will allow the ECU to erase some specific error when are yet latent. So the mill lamp, the check engine light, it isn't turned on yet. Okay? So obviously this is made automatically by the ECU and only while we are driving on gas, okay. So we usually provide a little set of error codes that are a target of this feature, even if some software customization has its own. However, selected error codes that we put inside are usually false positive errors. I mean conditions that are detected as errors by Petrol ECU while we are on gas, but we know for sure that are not errors at all. Okay? However, let's have a try. Now selective errors erase is great, because it's not enabled here. Now I enable it. Well, it turns red. By clicking here you get some information about. So, in this case, ECU is on Petrol, error list not available. This is because while we are on Petrol we are not monitoring these latent errors, okay? So while we are on Petrol you haven't any information about. And gas. Well, you see here a green button. By clicking here, no error found. So, green means that there is no latent error at all. Okay, so you didn't see anything. Well, so we are monitoring the situation. The gas ECU is asking to the Petrol ECU if some latent error is there, but there isn't. Well, I now will disconnect the fan sensor just to make you see how this feature works, okay? You obviously no need at all to disconnect it. Well, let me a second to do this. Okay, you now see yellow button, okay? The ECU is telling you, yeah, I found an error to erase, but it's not on the list. To check which error is, simply click on the button. Here's the code, P0115. As you see here, errors found, erase not provided. So if the ECU found an error like this, it will not send an erase error request. Yeah, now I can reconnect the button. Please wait another second. Okay, now I have reconnect the sensor and disconnect another one. The previous sensor, the fan sensor, is reconnected, and I disconnected another one that is in the list. So the Petrol ECU is finding an error. It's you can see here by clicking. Okay, P0110. I put this error in the list just to make you see how it works. Okay. So you see that it's flashing from green to pale blue because it's the Petrol ECU is detecting the errors. The gas ECU is erasing it now, and due to the fact that the error is permanent, is fixed, I not reconnect the sensor. We are trying all the times to erase it. So it's been erased and then it turns on, it's been erased and it turns on. Okay, this is the how it works, the selective errors erase. Now I reconnect all the sensor. Okay, now we can remove selective errors erase. Okay, here it is. Well, now let's see erase mill on K-on feature. This one. Okay, well, basically this feature sends just a single DTC errors erase command every time you turn on the key. If it works or not could depend from the OBD system of the vehicle. Anyway, every system allows an error erase if the key is on, and the engine is off. So if the customer waits some second after turning on the key without turning on the engine, the DTC errors erase will be successful. Even the owner of the vehicle can check it. Okay, so let's have a try. Now I turn off the engine. Okay. So basically, if he takes a look to the switch when turning on the key, he will see that the diagnosis LED blinking for some seconds. When it stops, the gas ECU is already connected with OBD system and has already sent a DTC error erase command. Okay, so let's try this. I turn on the key. So you see for a second here blinking the check on the switch, and you see here that the circle is turned to pale blue. Okay, so this means that everything is go in the right way and the DTC error command has been sent to the Petrol ECU. Well, this little circle could be even grayed. If it remains gray, it means that the gas ECU cannot connect for some reason to the OBD while turning on the key. Okay, and it could become even yellow if there's some strange answer from the Petrol ECU or not answer at all about the DTC erase error request. Well, about the erase mill on key off, this one. Okay, somewhat like the key on one, but it's made on key off. Obviously it works properly only in the rare vehicles that have a timer on key off, and before turning off the power supply the OBD connection is still alive. I cannot simulate it in this demonstration because it's not so easy to find a vehicle that support this kind of feature. To end this page we need to see last feature, then the engine load reading. To see it we need a Valvetronic vehicle. This is not a Valvetronic vehicle obviously, but just to see how it works. Okay, we will tell to the ECU that this is Valvetronic 1. Here in configuration, set Valvetronic flag. Now that we have enabled it, now here with the Adaptivity, you will see engine load reading. Okay, basically before this there was no way to use any kind of Adaptivity on Valvetronic systems related to the lack of map signal. Well, now if you want to use an OBD Adaptivity on OBD systems, we can by enabling this. Now you see here that the reference is changing, you see here engine load reading. If I enable it, I'm not more taking the map signal from map, but I'm taking the load signal, this one. Okay, in this car is not possible to make you an example how it works. If you try with a Valvetronic car, for example BMW and so on, you will see that this cursor will move more or less as a not Valvetronic car, and you will see that Adaptivity will work. Okay, let's go on. Next section, configuration section. Okay, here you see only if we have RPM wire. Okay, only if we take the signal from RPM wire and not from injectors. You have here multi-spark ignition. Well, this function is used in all those vehicles that in cold start are sending set of pulses in the ignition coils, making a wrong RPM readout to be shown. Okay, so when enabled, the ECU will automatically filter the pulses in excess. Another new feature is this one, starting petrol cycles. This function allows to set a number of cycles to be done on petrol. when the engine is hot. So when you have gas start, when hot engine, you can select a number of cycles that will be made on petrol anyway. It's useful to wait for the start or to keep the petrol injector at the best efficiency. Okay, last but not least, we've added a counter for emergency start here. It works only if emergency start is enabled, and once enabled, you have here on the left the amount of remaining start. Let's try it. Now I turn off the vehicle, and I will start in emergency. Okay, let's start the car in emergency, and as you see here, we are already on gas, you know, and the number is 4 instead of 5. So it means that 4 emergency start are left. To restore the maximum value, press the reset button. Okay, next page, sensor. Well, here you can see a new flag named enable switch warning. Once enabled, the switch will show us that the ECU is switched over to petrol when it's in protection mode if very cold temperature is detected on temperature sensor. In order to make this feature work properly, low temperature protection must be enabled. You'll see that in this new version of software, we split the old diagnosis page that you see here in 2 pages. The first one is still the diagnosis, okay, while the other one is injectors. Another new feature is the ECU lock for service. You can find here in info. First of all, you have to set a scheduled service, for example 300 hours. Okay, usually when enabling scheduled service, you simply will make the switch beep at every vehicle start when the selected service hours are expired. Okay? Well, now you can change completely the behavior of this functionality, activating the feature Enable ECU Lock that is just became selectable. Let's enable it. Now you see an important notice that you have to read carefully. Locking the ECU by using a password does not allow anybody else to access the parameters in case of emergency. Who enters the password undertakes all the responsibility from this choice, both for legal and civil law. Do you want to enable ECU lock? Let's press yes. Okay, now you are prompted to enter an 8-character password. Let's put, for example, a simple password. Let me say 1, 2, 3, 4, 5, 6, 7, 8. Okay. Well, now the ECU is locked. Okay, so from this point, every time you connect to the locked ECU, you will be prompted to enter the password, and you have just 3 attempts. Okay, so if I disconnect and reconnect, takes a little bit. Okay, now we have to enter the password. You have 3 attempts. However, don't worry, if all 3 attempts fails, you will simply get disconnected from the ECU, and retrying the connection will prompt you again to enter the password. Okay, so don't worry about it. Okay. Anyway, if you connect to an ECU that you don't know the password, but you want to know some additional information about the ECU itself, simply when you get disconnected, you can browse every parameter of the locked ECU in offline mode. So, I will reconnect I will try to reconnect. I will put 3 times a wrong password. Okay, so you see that we are in offline mode, but we can see, even if we cannot change and access the ECU, we can see every parameters inside. Okay, it could be useful for some diagnosis and some troubleshooting. Now we'll connect to the ECU with the right password. Here it is. Okay. Okay, here we are. Moreover, it's very important to know that if ECU lock is enabled, when the scheduled service time expires, the ECU won't switch to gas anymore. To let the owner of the vehicle be aware of this with a forewarning, we've added this parameter, lock forewarning. By default is set on 30 hours, so in this case we've put 300 hours as a scheduled service. When we'll get 30 hours before expiring, so when the ECU counts about 270 hours of gas driving, the switch will beep at every vehicle start, allowing the customer to switch to gas, okay, and to go to the workshop. Once the 30 hours are expired too, the switch will beep again at every vehicle start, but the ECU will not switch to gas anymore, unless the installer, so in the workshop, it will be made a reset of the scheduled service. Well, now we can disable this ECU lock, okay, and then we go to the OBD Scan Tool tab. We don't need this anymore. Okay. So, to have OBD Scan Tool enabled, we need to be connected with the OBD systems, okay? So, for example, if we are not connected, so OBD Adaptivity is not enabled or frozen, you will see that OBD Scan Tool is not enabled, okay? So, you will have to go to Mapping before and enable OBD Adaptivity. Okay. Okay, now we are connected. We can leave Adaptivity enabled or frozen. It's not important. And then we have OBD Scan Tool enabled. Okay, so let's go on. This is the OBD Scan Tool tab. This is the first page we see. We are in the Selection tab. You'll see the list of supported PID of the vehicle. So from this list you can choose all the parameters you want to read. To do this, simply click on the parameter you want. For example, the engine speed, for example. Okay, and maybe air temperature or throttle position. Okay. And you'll see that some parameters have a red flag and are unselectable. Okay? This is because are fixed parameters that are always shown, obviously if supported by the OBD system of the vehicle. So once we have selected all the parameters we want to read, we can go to see the value of these parameters in the Value tab. Here it is. You can see here all the values of the parameters you have selected. So if there are some error present, the status of the fuel system bank, and we are in real-time reading. So you see here RPM changing and fuel trims changing. You see here the RPM speed of the engine, the advance of the first cylinder that we have selected before, the throttle position. Okay, so you can see here in real time all the values you have selected in the previous tab. Well, then we have three tabs: freeze, errors, and test results. They are related because are all part of the error management of the Petrol ECU. Okay, so let's go to see before the other one, the error tab. In the error tab you find the errors that have been stored in the ECU and that have turned on the check light. Now in this demonstration we have disconnected a sensor, the map sensor of the Petrol ECU. So you can see here the error. You see P0105, manifold absolute pressure, barometric pressure circuit malfunction. Okay, and we have the check engine light on. Then in the test result you will see what we call the latent errors. So some errors that are not the ones that make the check engine light turns on, and the one that we see here is the P0110 intake air temperature circuit malfunction. I have disconnected the temperature sensor of the air of the intake manifold, and you see here a list of the error, latent error. Okay, so at last in this tab, the freeze one, you have the all the condition in which was the vehicle when an error have been stored. Okay, so you see here P0105 error, the one you see here in errors. Okay, and you see all the condition in which was the vehicle when this error has been captured from the Petrol ECU. So when it happens, water temperature was, for example, 89 degrees, and the absolute manifold pressure was 10 kilopascal. The engine was stopped, so 0 RPM and 0 kilometer per hour, and so on. So you can see all the condition in which the check engine light have been turned on. This could be very useful when you make diagnosis on a vehicle that return to workshop. Then obviously, as an OBD scan tool, we can erase the errors that are stored in the ECU by clear mill. It's the same as making clear mill in the OBD Adaptivity tab. Okay, it's the same command. So now we can clear the error. Okay, now we return to errors tab, and then you see that there is no more error here, and no freeze frame. Okay, no information about stored DTC. Well, here we have the vehicle identification number, so it's unique for any kind of vehicle. Okay, usually it's not so useful, but it could be used for identificate a vehicle. And at last we have the print section here. So in every page of the OBD scan tool, it could be printed. Okay, so if you have mainly some need about checking and saving and some condition of the car, or do you want to save some error, some freeze frame that it's particularly valuable for you, you can Select the tab you want and then click on the printer icon, and you will see a little page that you can print or store or doing everything you want. And this is all. So, see you next time for further training. Bye.